Hi NET aspirants, after completing complex numbers, having 4 frames, 1 tutorial, 3 part 1, part 2, part 3, we are about to start the next chapter, sets, functions and groups, as it is mentioned in the KIPS manual. Without wasting time, question number 1 is, if x such that x is a recurring decimal, it is written in set builder notation, x such that x is a recurring decimal, and y such that y is a terminating decimal. X is a recurring decimal, x recurring decimal, recurring or repeating decimal, recurring decimal, while y is terminating or finite decimal, terminating or finite decimal. These are both definitions of rational number. It is a rational number, it is also rational number. Means x union y, the union of x and y is tantamount to q, means set of rational numbers. Means q, set of rational numbers. That is the definition of rational numbers. If it is in decimal, either the decimal repeats, recur after 1 digit, 2 digit, 3 digit, 4 digit, 5 digit, whatever the case is. A recurring decimal is known as rational number, as well as terminating decimal is also known as rational number. Rational number. They both can be written in the P over Q form, P over Q form. Everybody is familiar. Here, these are the two definitions. If we have fraction, if we divide, either we get terminating decimal or finite decimal, provided that P over Q such that Q does not equal to 0 and P, Q both belong to set Z of integers 0 plus minus 1 plus minus 2 and so on. If that is the definition of complex, rational number in P over Q form, where P, Q belongs to Z and Q does not equal to 0. If we simplify this, we will get two types of decimals: recurring or terminating, recurring or terminating, recurring or terminating. That is the whole definition of a rational number. We have in decimal, recurring as well as terminating. If we combine them, if we unite them, we will get the rational numbers. And furthermore, their intersection results in null set. They are mutually exclusive. Recurring decimals are not finite decimals, are terminating, and terminating decimals are not called recurring decimals. Means they are mutually exclusive. They are mutually exclusive. Mutually exclusive means they intersect in null set. They intersect in null set. So option number 1, part, this is true. The intersection is in null set, and if their union results in a rational number. So part number 2 and part number 3 are true. So option number B is true in that case. That is the definition of a rational number. X is equal to P over Q, where Q does not equal to 0 and PQ belongs to Z. Z means set of integers. That is known as the definition of rational number. If we simplify this fraction, we will get either recurring decimal, repeating decimal or terminating decimal. Recurring decimal or terminating decimal. Okay, that is the definition of rational number. If we find the intersection of recurring decimal is not a terminating decimal, while terminating decimal is not also a recurring decimal, they intersect in null set. They are mutually exclusive and their union is equal to rational number, rational number. Both of these options are present. These both options are true. Union is equal to rational numbers and their intersection is null set. So option number B suits us. The possibility second and third are true. Third are true. It is not true because rational and that is definition of rational numbers. And what about real irrational numbers? There is no concept of irrational numbers, and real numbers also comprises irrational numbers as well. Irrational numbers as well. So our right options are second and third part. They are both in present. Option B is true in that case. Recurring decimal is also known as rational number. Terminating or finite decimal is also known as rational number. If we simplify, write them in P over Q form, we will get P over Q, where PQ belongs to Z and Q does not equal to 0. Either we have given a fraction which simplify, we get recurring decimal or terminating decimal. That is the definition of rational numbers. In that case, recurring and terminating, their intersection is null set, while their union is whole rational numbers. Moving towards question number 2. We have given a matrix set A such that x is equal to A00A. Scalar type matrices. Scalar type matrices. Diagonal is non-zero and diagonal is same. Diagonal is non-zero and diagonal is same with respect to multiplication. Either it is monoid, non-abelian group, abelian group, or not a group. Monoid means inverse is missing. Let me write the criteria for a group. A star B belongs to G for all AB belongs to G. That is the definition of Closure property or binary operation. Closure property or binary operation. Number 1, for a group. Number 2, it also satisfies associative law. Associative law. What is the difference between these two? In that case, we have to start from left, manipulate first A and B, whatever the result is, manipulate with C. In that case, start from right. First manipulate B and C, whatever the result is, manipulate with E. It is known as associative law. Associative law. Number 2. Number 3, we have identity element. E is A star E or E star A. Always results in E, where E is identity element. Where E is identity element. The fourth one is the inverse. Inverse is denoted by a dash. A inverse or A inverse A always results in E, where A dash is inverse of A. Inverse of A. These are the 4 requirements for a group. It must be closed, satisfy, obey binary operation. It is given to us. Always it is given to us in case of group whether to check or not. That is star associative law. It is also valid. We have identity according to the given binary operation and inverse. Inverse identity associative closure property. Inverse identity associative closure property. These are the 4 requirements for a group. For a abelian group, we have 5th additional possibility. Sorry, condition is A star B is equal to B star A. For all AB belongs to G. They commute. They commute. They commute. They obey commutative law or abelian law. If these are the 4 conditions are met, it is a group. Along with these 4, 5th is met, it is known as abelian group. It is known as abelian group. Okay, now let's see. I have this type of matrix, A0, OA. If I multiply any matrix of this type, BO, OB, let's see what happens. It results in AB 0, 0, AB. It is same scalar type matrix we are getting. So we can claim that yes, it is closed according to multiplication of matrices. Why? We have given a scalar type matrix, diagonal same, diagonal same. If you multiply them, still we are getting the diagonal same. Yes, it is closed. Number 1 condition met. Closure property has been satisfied. Closure property has been met. Okay, number 2, identity, no doubt. A00A, according to multiplication, identity is 1001. We are familiar. It is also a scalar matrix, and where the diagonal is 1. If you multiply with them, still we get A00A. So here identity is also present. Identity is also present. What about inverse and associative law? Let's see and find out. I am erasing this, making a space for myself. Okay, what about inverse? Let's find inverse of this. Suppose it is A00A. What about A? We are familiar. What is the inverse of 2 by 2 matrix? change their positions, it will still remain same. Change the symbol of these two, it is also same. A0 0 a dividing by the determinant, that is a into a square minus 0. So we have a0 0 a divided by a square. I am dividing with each term. We get something 1 over a 0 0 1 over a. It is still a scalar matrix. It is a scalar matrix. A matrix of this type. A matrix of this type means inverse also exists. Inverse also exists. So here we have met, identity is there, inverse is there. What about associative law? It also obeys the associative law. Let's see and find out how. We have associative A0 0 a. Second is B0 0 b. Third is C0 C0 0 c. Either first manipulate this, then with this we are going to get AB0 0 AB. Then with C0 0 c. It is our ABC0 0 ABC. It is the matrix of the same type. It is the matrix of same type. Good. Associative law also prevails. If we first operate these two, then with this we will still get the same answer. We will still get the same answer. How? First take these two, B0 0 B, C0 0 C. We will get, it is BC0 0 BC. One can multiply. I am not bothering myself. A0 0 A with BC0 0 BC. We are going to get same ABC 0 0 ABC. So it has met all the four requirements of a group. Yes, it's a group. Yes, it's a group. But for the possibility, there is an abelian group. Abelian group. What about the extra mile to be traveled? Fifth condition. AB is equal to BA. Let's see. AB must be equal to BA for commutative. Fifth additional property for commutative group. It's our A0 0 A 0, sorry, B0 0 B is equal to B0 0 B A0 0 A. We will get AB0 0 AB. In that case, we have BA0 0 BA. AB as AB belongs to real numbers, AB belongs to real numbers, and real numbers are commutative. 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 Yes, it is an abelian group. It is an abelian group. It has met the all five requirements: clear property, inverse, associative, identity, along with fifth additional possibility. Condition AB is equal to BA for commutative group, abelian group. It has also been satisfied. It has been also been satisfied because in real numbers AB is equal to BA. In real numbers AB is equal to BA means all entries are same. So it is an abelian group under multiplication of matrices. Question number next. Question number 3 reads as, there are 50 people in a room. There are 50 people in a room. 28 are male. 28 are male and 32 are under the age of 30. And 32 are under the age of 30. 12 are male. 12 are males under the age of 30. 12 are males under the age of 30. How many females are the age of 30 in the group? We have some people, 50 people. How many people are there? 50. Okay. Next distinction is 28 are male. Male are 28 male. Furthermore, 32 people. 32 people means both male and female. People are under the age of 30. Under the age of 30. Okay, cool. 12 are males under the age of 12. 12 male under age of 30. And then we are asked how many females over the age of 30. How many females? We have to find females over 30. Females over the age of 30. Females over the age of 30. Let me draw a diagram. We have two categories, male, female. Collective part is 32 people. 32 people under the age of 30. 32 people encompasses both male and female. Both male and female. 32 people belongs here. It contains male as well as female under the age of 30. Under the age of 30. Okay. Furthermore, we have given how many males? 28 are males. 28 are males. 28 are males. Here we have to plug in the deficiency. 12 are the males under the age of 30. 12. So if I can split this as 32, let me write this 32. 12 plus 20. This is the ratio of figure of male under the age of 30, and this is the number of female under the age of 30. 32 in total. 32 people are under the age of 30. 32 are the people under the age of 30. I have written. Furthermore, we have given 12 are the members, 12 male members are the under age of 30. 12 male, 12 male. Then I have split up this 32 as 12 plus 20. 12 plus 20, it will become 32, 32, and they are all under the age of 30. 12 male while 20 female. And we have collectively males are 28. 12 plus 16. Look at this one. 12 plus 16, 28 male. 12 plus 16, 28 male we have combined. Okay. Now how much we have? 16 plus 12 plus 20. 16 plus 12. 16 plus 12 plus 20 plus x must be equal to 50. As to calculate the total number, we have total number 50. We have 16 male under the age of over the age of 30, over the age of 30, and 12 under the age of and 12 under the age of 30, and there are 20 females. 20 females. Add them. 16, 12, 28, and it will become 48. 48 plus x is equal to 50, or x is equal to 50 minus 48. So there are two females only, that are over the age of 30. Over the age of 30. Only two females, two females, two females. Now you can calculate your total. 16 plus 12, I have written 28. 28 plus 20, it will become 48. 48 plus 2, 50. 48 plus 50, that is the collective portion of the people who are under the age of 30. Who are under the age of 30. 32, how I split it is given to us. 12 male, then 20 female. 12 male under the age of 30, 20 females are under the age of 30. Total male members are 28. 12 under the age, then 16 there. 12 plus 16, it will become 28. Two types of age. Less than 30, under the age of 30, over the age of 30. Under the age of 30, over the age of 30. Collectively, they are 20. Collectively, they are 28. Females, 20 are the under the age of 20. 2 are the females that are above the age of 30. And we are interested in that. So our answer in that case is 2. Our answer in that case is 2. Moving towards next question. How to read this Z integers under subtraction? Z integers under the operation subtraction, where Z is a set of integers. We have to prove or disprove it is a group, not a group, semi group, monoid, whatever it is, whatever it is. We have Z integers. That means 0 plus minus 1 plus minus 2 plus minus 3 plus minus 4. I have just written the 4 requirements for a group. Let's verify. Number 1. Number 1. It is clear property. A star B belongs to G for all AB belongs to G. Here our operation is integers under subtraction. So A minus B must belong to Z for all AB belongs to Z. If we subtract any two integers, result is again integer. A minus B, then if suppose it is equal to C, then C must belong to Z because difference of any two integers is also integer. Difference of any two integers is also integer. So clear property has been satisfied. Or one take elements like a child, 2 minus 3, 3 minus 2, minus 4 minus 7, minus 4, whatever the case is. But you should have the generalization. Difference of any two integers is another integer. Difference of two integers is another integer. Okay. So first condition has been met. What about second? What about C? What about inverse? There is A. We must have minus A. Every integer has its additive inverse. A then minus A, minus A then positive A. Inverse also exists in this case. Inverse also exists in that case. What about associative law? Let's see and find out. Associative law. Point to be noted, my lord. Associative law. Associative law means A minus B minus C. A is equal to A minus B minus C. It is A minus B minus C. If we multiply minus A minus B plus C. So associative law fails under subtraction of integers. Associative law fails. Associative law fails. Here, first we have to calculate AB, then whatever the result with C. Here we have to calculate B minus C, then with A. If I multiply by minus, look at this. There is A minus B minus C, there is A minus plus C. They are not equal. They are not equal. So it has satisfied only one condition. It is closed, it has inverse. It is closed, it has inverse. It is closed, it has inverse. It also has identity. It also has identity. 0 is the identity in that case. If we subtract 0 from any number, still we will get 0. 0 is the identity under subtraction. 0 is identity under subtraction. So three conditions have been met. Three conditions have been met in that case. So it is, or I think, no, monad as inverse. Semi-group means inverse as well as associative. So it is safe to claim it is a groupoid. For groupoid, there must be only clear property satisfied. Clear property satisfied. Clear property satisfied. However, it satisfies the three conditions. It is closed under subtraction. If we subtract any two integers, we will get another integer. For every integer, we have its inverse, additive inverse. Minus 2 plus 2, minus 3 plus 3, plus 3 minus 3, plus 4 minus 4. It has inverse. It has inverse. What about identity? 0 is the identity under addition as well as subtraction. 0 is the identity. If we add or subtract 0 from any number, we will still get the same number. We will still get the same number. Where lies the fault? That is the flaw under subtraction. Associative law fails. Associative law fails. Associative law fails. So according to the requirement, three conditions has been met, and for this semi-group, how many requirements are there? It must be, it must have at least 2 to 3 properties. Monad without inverse, no inverse. It means it has clear property. It has clear property. So it is safe. It must be a semi-group. It must be a semi-group. Definition must be checked. Definition must be checked. I am 100% satisfied that it satisfied clear property. It has identity according to subtraction. It has inverse according to subtraction, while associative law fails. While associative law fails. While associative law fails. Moving towards the next question. Moving towards the next question, what it is? Let's see and find out. Let's see and find out what it has been. Uh, what it has been. Which of the following is not true? Which of the following is not true? Where it is not true? In that case, yes. Set A belongs to itself a set where A is its member. It's true. It's true because this complete lies here. It is the member here. It is a member here. Yes, it is true. We are asked to find what is not true. How we can write if there is A, we write A belongs to this. A belongs to this. We remove this curly bracket. We remove this curly bracket. However, here two curly brackets are present. Two curly brackets are present. If we remove first, then we write curly bracket in A belongs to double curly bracket in A. It's satisfied. It's satisfied. Yes, it is true. Yes, it is true. What about second? A mind boggler type, but simple one as well. How to reconcile yourself? Whether this is true or not. Whether this is true or not. you you will hardly able to crack this nut. However, if you get this set, how many elements are there? 1, 2 power 1. Write its subset. Its subsets are null set and itself. Null set and itself. Null set and itself. From this you can deduce that it is not true. From this you can conclude that it is not true. Curly bracket in A is not a subset of A in double curly bracket. It means it is a set having set A as a member. It is a set having set A as a member of it. This is a set in which set A is a member of this one. So this is not subset of this one. It is not true. How we have reconciled ourselves? Find its subset, power set. One element 2 power 1, it has two possible subsets, null set and itself, null set and itself, null set and itself. From this we can deduce it is not true. It is not true. It is not true. However, C is true. See, this is always true. A belongs to, A is a member of this one, it is true. Good. Moving towards sixth question. The second last of today. Good. Second last. If A function is written A to 2, B to 1, C to T is an injective function or a mapping, same thing. Function is also called mapping, is injective from, it's a function from A. What is our A? A is our A, B, C to B. What is our B? 1, 2, 3, 4 and 5. Now, then which of the following is true? Then which of the following is true? One, injective means each element has unique inverse. Each element has unique inverse. Here, domain has A, B, C, while range 1, 2, 3, 4, 5. A to 2, B to 1, C to, for injective function, C may be related to 3. It's true. If we take this one, so value of T is 3. It is injective. Good one. Another possibility. Here it is A, B, C. There is 1, 2, 3, 4, and 5. P with 1, A with 2. P with 1, A with 2. Or you can take C with 4. It's 2. Then it is also, write this possibility C3, it is injective then. If I write C3, it's injective. A to 2, B to 1, C to 3. C to 3, it is injective. If instead of T, I write 4, C4 here. If I include C4 here, it's also injective. If I put instead of T5, it's also injective. It's also injective means different element has different image, unique image, not more than one. Unique. Let me clarify the situation further. We have A, B, possibility number one, A, B, C. We have 1, 2, I am taking 3. This is to this one, A to 2, C to 3. Look at this. Different element has different images. A to 2, B to 1, C to 3. There's no repetition. There's no repetition. It's a injective function. If instead of 3 I take 4 from the range, that is A, B, C, that is mine 1, 2, 3, B to 1, A to 2, then C to 3 I have taken, C to 4, C to 4, then A to 2, B to 1, C to 4, it is also injective. It's also injective. This is 2 if T is equal to 3. This is 2 if T is equal to 4. And instead of this 4 I take 5, it's also 2. Like as, let me write the final possibility here. A, B, C, 1 to 5. B to 1, A to 2, C to 5. It is also injective. A to 2, B to 1, C to 5. They are all injective. If we put T is equal to 5, it's injective. If we put T is equal to 3, it is still injective. If we T put 4, it is also injective. Injective means 1 to 1 corresponding, almost 1 to 1 corresponding. Maybe there are 4 and 5, they are missing, it's okay. From, but 1 to 1 correspondence lies 1 to 1, 1 to 1. B to 1, A to 2, C to 3. Then instead of 3, 4. Then C can be plugged into, C can be related to 4, C can be related to 5. For C we have 3 possibilities and they are all injective. And they are all injective. Means what should be the option? It might be T is equal to 3, T is equal to 4 and T is equal to 5. They are all the possibilities. They are all the possibilities to make this function injective. To make this function injective. Moving towards final question. If we have A is equal to X such that X square is equal to 1. A is equal to X such that X square is equal to 1. And B is and B is X such that X4 is equal to 1. X4 is equal to 1. Then B minus A minus A minus B. What is the difference of B minus A and A minus B? What is the difference of B minus A and A minus B? Let these are given in set builder notation. Let's translate them into tabular form. We have for A, X square is equal to 1. If I shift 1 here, X square minus 1 in order to give you good view. Factorize difference of 2 square means X is equal to minus 1 and X is equal to 1. R1 can take a square root here is positive, negative, it's also okay. It's also okay. So value of A is plus minus 1. Cool. What about B? B is X4 is equal to 1. Shift 1 here. X4 minus 1. Factorize the quadratic difference of 2 square. X square plus 1. X square minus 1 is equal to 0. Here it can be written as X square plus 1 is equal to 0 or X square minus 1 is equal to 0. Here it will be X minus 1 and X plus 1. It will give us X is equal to 1 and X is equal to minus 1. In that case, X square is equal to minus 1. Removing the square, taking the square root. The square root of minus 1 is, square root is always in positive, negative. X is equal to plus minus iota. Plus minus iota. Or one can factorize X square plus 1 as X square plus 1. It can be written as X square minus iota square. Iota square is equal to minus 1 minus plus 1, we will get same. Instead of plus, I have written minus iota square. Minus iota square is equal to minus 1 minus plus. I will get this. So from this, I can easily factorize x minus iota, x plus iota. So x is equal to iota and x is equal to minus iota. So value of A is plus minus iota and value of B are plus minus 1 and plus minus iota. Plus minus 1 and plus minus iota. Plus minus 1 and plus minus iota. Let me fill the values. It's plus minus iota. Sorry, plus minus 1, and B is mine plus minus 1 and plus minus iota. What is required? Now find out. Now find out. It will be B minus A and A minus. The difference of B minus A and A minus. We are interested in their difference. In their difference. B minus. What is our B? Plus minus 1 plus minus iota. Minus plus minus 1 for these two brackets. Minus, what is A? It's plus minus 1. What's B? Plus minus 1 and plus minus iota. Subtract. Whatever is remaining in the first set, we have to write plus minus iota. Minus. In that case, this and this has been cancelled out. They have been cancelled out. Whatever remains in the first set, we have to write. We don't take the remaining elements of the second set. Do. We are interested in the remaining of this one. They are cancelled out. In first set, nothing remains means null set. If we remove null set from this, we will get same plus minus iota, plus minus iota. So that is our answer in that case, that is C plus minus iota. From the difference we are familiar, A minus B. If A comprises AB and this comprises CD, okay, AD. A cancel. Whatever remains in the first set, we have to write. It's our answer. We don't take this. We don't take this. That is the way of subsetting two sets. Whatever remains in the first set, we have to write. If there something remains, if not, then not. We are not interested in the remaining part of the set to be subtracted. Set to be subtracted. So in that case, plus minus 1 plus minus cancel out. In the second set remains plus minus iota. We are not interested in it. Whatever remains in the first set, it is our result. It is our result. So in that case, our answer is plus minus iota. It's my tiny effort for you guys to shed some light on sets, function, and groups. What is coming? Let's see and find out. It's all by itself next.